Welcome to Mastering Solutions. In this question, if we make a list of what we're given, we're told that the image distance, or S prime, is 7.2 millimeters. Milli is 10 to the negative 3, so 7.2 times 10 to the negative 3 is standard units. And we are told that the amber has an index of refraction of 1.54. So N is 1.54. It's surrounded by air, they say. And obviously we're going to assume that it's surrounded by air since we're holding it. And now the equation that we're going to use, we're going to come back to this in just a second, but the equation that we'll be using to solve for this, it's given in the book, but it derives from Snell's law. But what it says is the image distance is equal to N2 divided by N1 times the object distance, or S. We're trying to figure out S, or the object distance. That's what we need, right? And now this can be confusing on trying to figure out which N goes where, but the book addresses that and they say that N1 is where the object is, N2 is from what the observer is seeing. So for us, the N1, of course, is going to be the amber, and N2 that we're observing it in is going to be the air, or the N of 1. And so now we need to rearrange this to solve for S. And so we'll divide both sides by N2 over N1. And so S is equal to S prime over N2 divided by N1. We're dividing by a fraction, so we can simplify it a step further by multiplying by the inverse. So S is equal to S prime times N1 over N2. Now we have the image distance they said was 7 millimeters. And then we're multiplying that by the N1 is the object. And so that we said was 1.54. 1.54. We're dividing it by what the observer in, which is 1. So that gives us let's see, that's in meters. So we have 1, 2, 3. So 10.78 millimeters. And if we round that, of course, that'll be 11 millimeters. So the distance down to the air bubble is 11 millimeters. And that's how long of a needle they'll need.